the caffeine experiment. So in this experiment, you use caffeine, water, hexane, ethyl acetate, and DCM. So you extract caffeine from tea leaves. The aqueous solution is the caffeine plus the sodium carbonate. You use anhydrous sulfate to absorb water. The sodium carbonate helps make everything basic. It is used to convert acid into salts. Basic mediums are only used in this extraction. Tannins pose a serious threat because they are acidic, so the sodium carbonate helps make everything basic. And like I said before, it is used to convert acid into salts. So for the layers, there are two layers: there's an aqueous layer and an organic layer. The organic layer is DCM plus caffeine, and the aqueous layer is the caffeine plus the sodium carbonate and the tannins. In this experiment, you use water. The water is dried with aqueous sodium sulfate. The aqueous layer is the DCM plus the caffeine. You use TLC to identify compounds in the mixture. So a spot of mixture solution is added to the plate, and the plate converts the components. The plate has silica on it, which is the white stuff, and silica is polar. The less polar travels further on the plate, and that means it doesn't mix well with the silica. The polar travels slower. It has a larger weight, and it mixes well with the silica. And polar means it has hydrogen bonding, and it has polar bondings. The rate of movement depends on what gets attracted the most. The fast spend more time being dissolved. Slow is absorbed more by the silica. So the furthest one is non-polar, and the shortest distance is the polar one. The TCL is the retention factor. You use the RF value, which measures the relative distance. 0% means no movement, 1 means movement. Distance is measured from the baseline to the total distance. So in order to calculate the RF, you do the distance from the baseline to the point, and then you do the distance from the baseline to the topmost line on the TCL plate. And you use the rotovap to get the crystals. The solution must be clear. Anhydrous sulfate is added to make the solution clear.